Okay. So make sure your puzzle's away at this point. I want you to focus on this. By the way, if you want to write 10, 15, or 11:15 on that puzzle, that's when it's due if you're interested in turning it in. Okay, so this is the first 6 games of the Vikings this year. I know that they've played a couple more, but this is the first 6. And we're going to talk about standard deviation today. Anybody know what standard deviation already is? Have you heard the words before, standard deviation? It's kind of familiar, not really though? Okay. All right, so do you guys remember what a sample mean, what that symbol for that was? It looked like this. Remember what it was called? X bar, yeah. Everybody write it down. That's just a sample mean. It just means if you take the average of a sample. Just a symbol that represents that. The symbol that represents population mean looks like this. It's like a U with like kind of a long tail out front. This is not an M. So make it like you would a U with kind of a tail out front, and that is pronounced mu. It's a Greek letter. There is absolutely no difference in how you calculate a sample mean or a population mean. The only difference is just the symbol that's used to show you that they were looking at a sample or a population. But it's still like adding it all up and dividing by how many you have. All right, now a deviation is how far a point deviates from the mean. Okay, so let's say that we had stats on how many black eyes people have gotten in their lives, okay? And let's say up until high school, the average is 2. All right, so sometime in your life, you've gotten 2 black eyes maybe from whatever you were doing. All right, now, Andon, how many black eyes have you gotten for real? 1. So Andon's deviation would be -1 because he's 1 under the average. Does everybody understand that? Alex, how many black eyes do you think you've gotten in your life? So his would be +1 because he's 1 above the average. So a deviation can be positive or negative. And the formula is x minus mu. So in this case, we were talking about black eyes. And we said that our mu was 2, and then Andon said that his number was 1, and Alex said his number was 3. And 1 minus 2, Andon's deviation is -1, and Alex is 3 minus 2, Alex's deviation is +1. A standard deviation is the average deviation. For example, if, let's say that I was talking about black eyes and everybody in this room was exactly 2. We were all exactly 2 black eyes. I know it didn't happen, right? Because we know Alex is 3 and Andon is 1, but let's say that everybody was exactly 2. We would all be exactly on average, which means our standard deviation would be 0. On average, we don't deviate at all. We're right on. Okay? If everybody in here had a standard or had a answer of either 3 or 1, they were 1 away from the average, our standard deviation would be 1. We're all about 1 away from the average. It tells you how spread out your data is. Okay? We're not going to write a formula yet because we're actually going to come up with the formula together. So we'll go back to that. All right, so I'm going to write this out. Yeah, is it important?
My dentist, I
Okay.
think.
So we're gonna do an example at the same time as writing it out in words and symbols, okay? Because I'm gonna try to teach you, like, I'm really proud of this lesson actually, because I've worked really hard at it, because standard deviation is one of those things that kids have a really hard time with. And we're gonna figure it out together. There's gonna be directions in words, there's gonna be directions in symbols, and then there's gonna be an example on the next page, and we're gonna do all of them at once. Okay, so we're trying to find the average deviation. So first of all, to find a deviation in the first place, which is how far you are from the average, the first thing we have to do is find an average, right? So the first step is to find the mean of the data set. And if I was going to write that in symbols, I would say, well, mu, which is what population mean is the summation of all of the data, and then you divide by capital N, where capital N is the total number of data points you have. Should we write maybe on the bottom of this list kind of like a key for all of these little things? Okay, so down here I'm going to write, right at the bottom, I'm going to write mu is population mean. This is pronounced sigma, but it is, it means summation. That means you add them all up. X are your data points. And capital N is the total number of data points you have. Okay, so we're going to then move over to the population standard deviation example we're going to do. So on the example, I want you to make a chart. And you're going to make it 7 rows and 3 columns. The data points I'm going to put in is the scores of the Vikings, their first 6 games. Looks like out of the first 6 games, they won 3 and lost 3. But this isn't about whether they're a good team. This is about how consistent they are. Okay? Standard deviation is about consistency. In fact, I'm going to go back to the population standard deviation definition at the beginning and write consistency. What would it look like if we had a football team who always scored 30 points in a game, always. Every single game, they scored 30 points. What would their standard deviation be? What? Nope, it'd be 0. Their average would be 30, but how far they vary would be 0 because they're always consistent. 30 points is a pretty good score for a game, right? Okay, what about if they always scored 0 points? Always, every single game, they always got 0 points. What would their standard deviation be? 0. So do you guys understand that standard deviation is not a representative of how good you are at a game? It's just how consistent you are. You could be consistently horrible, or you could be consistently awesome. Or you could be the kind of team that scores on average 20